Hello there, welcome to section 4 of this unit. And for this section, we'll be looking at vapors. Let's look at the objectives of this section. The first objective is to be able to explain saturated vapor and unsaturated vapor. And lastly, be able to explain the three phases of substances. So with our illustrative experiment here, let's look at the isotherm of a substance below a critical temperature. What is a critical temperature? A critical temperature of a substance is the temperature at and above which vapor of a substance cannot be liquefied, no matter how much press is applied to it. Now let's look at a diagram that we have below here. So if you take a liquid, say water for example, and start heating it at atmospheric pressure, the temperature increases, right? It corresponds to the following horizontal line, and that is pressure. Under liquid state, the vapor is small, hence it corresponds to the left region of the graph. If you keep heating the liquid, it will start turning into vapor. When temperature is 100 degrees, at this point, the temperature and the pressure will remain constant while the liquid will keep turning into what? Vapor as you heat it. In this configuration, the vapor is said to be saturated because it is still what? Liquid water. And this one we can see from between A, B, and what? And C. That's where our dotted line is. The conclusion is that 100 degrees Celsius, at 100 degrees Celsius, the saturated pressure is what? 1 atm. That's 1 atmospheric temperature. That's 1 atmosphere. If now you close the recipient where you have your water, like the one that we have in the pressure cooker, the pressure will start increasing as more and more vapor is formed, because they are all accumulated in the pressure cooker. And that will correspond to the following vertical lines from the graph that we have here. In that case, as you keep heating, the water will start boiling again at higher temperature. The conclusion this time will be that at, let's say, 120 degrees Celsius, the saturated pressure is a bit more than what? 1 atm. The saturated pressure is described by the dotted red lines. Let me use this dotted red lines that I'm drawing now. Let's look at a phase diagram here and the three phases of a substance. So a phase diagram is a graphical representation of the physical state of a substance under different conditions of temperature and pressure. A typical phase diagram has pressure on the y-axis as shown here, and also temperature on the x-axis. And here you can see a red dotted line here. That is the critical point and the triple point. So the triple point is the point on the phase diagram at which the three phases of matter, that's the gas, liquid, and solid, coexist. The critical point 2 is a point on the phase diagram at which the substance is indistinguishable between the liquid and the gaseous state. So the phase diagram plots pressure versus temperature. Here, the labels of the graph represent a stable state of a system in equilibrium. The lines represent the combination of pressures and temperatures at which two phases can coexist in equilibrium. In other words, these lines define phase change points. The red line divides the solid and the gas phases. Represents sublimation, and we know sublimation is from what? Solid to gas. And deposition, that is the reverse of sublimation, that is from gas to solid. The green line divides the solid and gas phases and represents melting, that is from solid to liquid, and freezing, that is the inverse of it, from liquid to solid. The blue line divides the liquid and gas phases, represents evaporation and condensation, that is from liquid to gas and also gas to liquid. There are also two important points on the diagram here, that is the triple point and the critical point, which I've defined earlier. The triple point represents the combination of pressure and temperature that facilitates all the phases of matter at equilibrium, whilst the critical point terminates the liquid or the gases phase line and relates to a critical pressure, the pressure above which a supercritical fluid is formed. With most substances, the temperature and pressure relate to the triple point lies below the standard temperature and pressure, and the pressure for the critical point lies above the standard pressure. Therefore, as standard pressure, as temperature increases, most substances change from solid to liquid and to gas. And the standard temperature, as pressure increases, most substances also change from what? A gas to liquid to solid. Okay, so from the explanation that we've had from the saturated vapor and the unsaturated vapor, we can see that from the diagram that we've shown on the previous slides, that for the saturated vapor, we have what? A horizontal line due to what? A constant what? P, pressure. Unlike the unsaturated, where we have a variation in pressure and volume. So an unsaturated vapor obeys both the what? The Boyle's law and the what? And the gases law. Therefore, we may apply equation of state of an ideal gas to a what? An unsaturated vapor. But in the situation for the saturated vapor is different. Thus, since the PV curve of the saturated vapor is what? Is horizontal, it follows that Boyle's law is definitely what? Not obeyed. So boiling. I believe you all understand boiling from our previous slides or previous sections.